Yo, today I'm going to be talking about factorization. So, what is factorization? Well, factorization is basically, the opposite of distribution. It's kind of splitting a polynomial apart. So, we'll start with factoring some monomials, like 36xy and 16x squared y to the third. So, just like how you could factor maybe 18 into 9 times 2 or into 3 times 6, there are multiple ways that you can factor a polynomial. So let's start with this 36xy. So try to pause the video and work this out on your own if you want to. And so now let's get started. So 36xy. So let's break it up into its prime factors. Okay. So 36 can be broken up into, let's say, 4 times 9, right? Which can be further broken up into 2 times 2 times 3 times 3, okay? And then of course we have times x and times y. And so we can have basically any combination of these factors right here. So let's do 2 times 2 times 2, that's 4, that's 12. How about 12x times 3y? Those are factors of 36xy. Let's do another one. We could do 4xy times 9. Okay, those are also factors of 36xy. So those are just a few. If you worked them on your own, you might have gotten some different answers, but remember, there's a bunch of different ways, or a bunch of different factors of polynomials, okay? So let's do 16x squared y to the third, okay? So let's start breaking this down. So 16 is basically 4 times 4. 4 times 4 can be broken up into 2 times 2 times 2 times 2, okay? Now let's take x squared. X squared is just 2 x's, so x times x. And y to the third is just 3y, so y times y times y, okay? And again, any combination of these, right? So I could do 2 times 2 times 2, so I could do 8x y squared times 2x y. It's very important to make sure that you're keeping track of everything and not, adding or taking away any variables or factors, right? So if I were to multiply these two numbers, I would get 16x to the second, y to the third, okay? Let's just do one more factor. Well, we could do 2 times 2 times 2 times 2, 16 times, 16x y, that was bad, y, times x y squared. So yeah, as you can see, you can factor polynomials in a bunch of different ways. They have a bunch of different factors, and it's very easy. You can just break them up into their base prime factors and make any combination of those. You can also factor other polynomials. So to factor a polynomial, you got to find the greatest common factor of the terms, or GCF. So GCF is like the largest monomial with the most variables to the highest power that you can divide each term evenly. So let me give you some examples. Let's do 12x squared plus 6xy. Okay. So try to work that on your own if you can. And so now let's work this out. So what would be the GCF of this? Okay. So let's first look at the coefficients. Okay. So what's the greatest common factor of 12 and 6? 6, right? Because 12 can be evenly divided by 6, and 6 can be evenly divided by 6. So we know that the coefficient of the GCF is going to be a 6. Now let's look at the variables. So what I like to do is I just go along at each variable and look at the lowest power variable, okay? So we got x squared and x, okay? So what's the greatest common factor of x squared and x? It's x, right? Because I can divide x squared by x and get x, and I can divide x by x and get 1, okay? So we know that for the x variable, GCF is going to be x, okay? Now let's look at the y, okay? So notice how for the 12x squared, we don't have a y. I mean, we technically do, but it's just y to the 0th power, okay? And this is y to the 1st. So we're going to have y to the 0th power as our GCF, which is just nothing, just 1, right? So it's just going to be times 1. So we know that our GCF is going to be 6x. Now that we factor out the GCF, let's complete the problem and find the other factor. So if we know that our GCF is 6x, then we basically just divide each term by 6x. So what's 12 x squared divided by 6x? That's 2x, okay? Plus what? Well, what's 6x divided by, or 6xy divided by 6x? And that's just 1y, or just y. So there's our answer right there. So 12x squared plus 6xy factors to 6x times 2x plus y. Let's do another one. So let's do 15x cubed y plus 10x squared y plus plus 5xy, okay? Fix that, okay. So let's start looking at the coefficient, okay? So let's 15, 10, and 5. What is the largest number that you can divide all of them by, and they'll get you integer, okay? Well, 15, 10, and 5 can all be divided by 5 and get an even number, or sorry, an integer. So we know that the coefficient of our GCF is going to be 5. Okay, so now let's look at the first variable, x. Okay, so what is the lowest? I just like to look for the lowest power of x. Okay, so we have x to the third, x to the second, and x to the first. So we know that our GCF for the x is going to be just x. Okay, now let's look for the y. So y to the first, y to the first, y to the first. So they're all divisible by y, so it's 5xy. So that the 5xy is your GCF. So now that we factor that out, let's see what our other factor is, okay? So 15x to the third y divided by 5xy is going to be 3 times x squared, okay? Now, what's 10x squared y divided by 5xy? Well, that's going to be 2x. Now, oh sorry, yeah, it's just 2x, plus 5xy divided by 5xy, and that's just 1, okay? Remember, it's very important to write 1 instead of just writing 0, because 5xy, it's not 5xy minus 5xy, it's 5xy divided by 5xy. It's just very important, because that one can change the whole answer, okay? And that's our solution. Okay, now let's talk about factoring quadratic expressions, okay? Now let's talk about factoring quadratic expressions. So let me start with, how about x squared plus 5x plus 6, okay? That's the first one. Our second one's going to be 3x squared plus 7x plus 4, okay? So I think when factoring, there's two main groups of quadratic expressions. One where it's just 1 times x squared, and the other is where it's not 1 times x squared, okay? So let's start talking about when it's just 1 times x squared, okay? How you can easily factor that, because what we know is that when it's in the quadratic form is that it's going to factor into x plus something, right, times x plus something else, okay? And what we know is that, and if you can even check this using FOIL, is that this number or integer times this integer is going to be equal to 6, okay? But what we also know is that this integer plus this integer is going to be equal to 5, okay? So we have to look at factors of 6 that add up to 5, okay? So let's just start with some factors of 6. Well, 6 is a very simple number, so it's either 1 and 6, right? What's 1 plus 6? 7, so that's a no, okay? What's another factor? 2 and 3, and that is equal to 5, so that's a yes. So we know that it's going to be a 2 and a 3. So x squared plus 5x plus 6 factors into x plus 2 times x plus 3. Now, for the second main quadratic for factoring is when it's not 1, an integer that's not 1 times x squared. So how we do this is going to be 3x plus something times x plus something, okay? So how can we do this? We know that this integer times this integer is going to be equal to 4, right? And now we have to find, okay, well, this integer plus this integer is going to be equal to 7. Well, that works for this one, but for this one it does not, because we are multiplying. If just simple FOIL, we have this integer times this x, right? It's going to be, something x, right? But then for this integer, what is that being multiplied by? Which x is that being multiplied by? And that's 3x. So what we do is that instead of just writing it as what are factors of 4, we write it as factors of 3 times 4, 12, that add up to 7, okay? So, just looking at this, I know that the factors of 12 that add up to 7 are 3 and 4, right? So, that checks out. So, what I usually do is I look for whichever one is divisible by this number right here. So 3, whichever one's divisible by 3, and 3 is divisible by 3, right? So what I do is that I know that I just put this first, the one that isn't divisible by 3 as normal, so 3x plus 4. And then when I'm doing the other one, the one that is divisible by 3, I divide it by 3. So it's not x plus 3, but it's x plus 1, okay? So 3x squared plus 7x plus 4 factors into 3x plus 4 times x plus 1. And, if you're having trouble understanding this or want to see more examples, I suggest checking out Khan Academy, where it provides plenty of examples and perspectives.